Good evening, everyone. I hope I am audible to all of you. Please write on the chat if I am audible. Yeah, okay. So I welcome you all to the sixth day of our training machine learning using Python. So we'll wait for 2 more minutes so that all the participants can join. So you can just tell your friends and colleagues and tell them to join. Tell them to join fast. You can see very less number of crowd right now. So tell them to join fast. No, Tech Talks certificate will be provided after the completion of this training. We have 1 more week left. No, we don't provide for internship. So I hope you have practiced and done all the things that we have done in the last week. Everything that we have done, everything have you done that? No, we don't provide that thing. Yes, good evening. So what we have covered in the last session, the last topic that we covered was feature engineering, right? I explained about feature scaling. I explained about feature encoding, and I explained about outliers. So basically, I explained the concept of these three, how we can do these three things, like how we can scale the data, how we can normalize the data, how we can encode the features, how we can find out the outliers. So theoretically, I explained everything, these three things in the last session. Today, we will do that in practical way. We'll understand how practically we can do all these three things by taking an example of a data. Okay. So in a data, we'll provide that, we'll apply these things and we'll see how practically we can do these things. Okay. Now, okay, in some day I will see that, Pinky. If I'll get time, I'll see that later on. Okay. So the first thing that I'm going to discuss is your feature scaling. Okay. First thing that I'm going to discuss is your feature. Or first of all, let us import the data set. Okay. Now, not audible. Krishna, please check your side. I think there is a problem in your side. Check your volume. Because I think I am audible to everyone, right? Collab link I have provided on the chat. Check your chat. I have pinned the message for the collab link. So check it there. Okay. Those who are getting my voice low, please increase your volume. I think your volume is low because I am speaking louder. Okay. And I don't think my voice is low. Or if you are using without headphone, please use the headphone. Maybe without headphone, you are getting the low voice. Okay. Please use your headphones if you are not using. So first of all, we will import the data set. Okay. And in the last class, we used the data set, which data set we have used in the last class for the pandas. Which data set we have used, if you remember, tell me. You remember that? Employee data set, correct. We have used the employees data set. Today I am going to use Titanic data set, which I have given you for the practice also in the last class, if you remember. So that data set I'm going to use, and I'm not going to use the CSV file. I'm going to import from the library. The library, Seaborn library itself contain this data set. I can import directly from there also. So how to do that? First of all, I'll import the libraries. So let me import all the libraries that I require. So one is your Seaborn, then another one is your pandas as PD. Let me import NumPy also in case if I have to use, I will use that. And let me import matplotlib also. So these are some libraries which I am going to import now. Okay. Now let's import the data set. So I'll take a variable data is equal to PD. So not PD, we'll not import using pandas, we'll use Seaborn. Now, one more thing, let me show that to you. This Seaborn contains so many data set. Just a minute. Oh, I've given the wrong spelling. My mistake. Okay. Now, this Seaborn contains so many libraries. If you write here sns.get underscore data set, you'll get the list of libraries that this Seaborn contains. Get underscore data sets. Just a minute. There are so many functions, I don't remember. Let me check this. Get dataset names. Yeah, this is the function. Okay. Now you can see here, these are the available data set that we have in this Seaborn. Like 10 to 15 data sets are there. Anagrams, Anscombe, attention, brain networks, car crashes, okay, diamonds dot, all these things we are having here. Data, the collab link is provided in the chat as a pinned message. Check as a pinned message I provided. If you want it again, I'll provide that again. But as a pinned message, it is there. You can check that. Check it. Okay. So these are some data set that is available in the Seaborn. Sorry. So out of these, we are going to use one Titanic for today. Okay. And later on, you can explore the other data set also. You can check what we are having here. Okay. So right now we are going to import this one. So I'll write here sns.load underscore data. Load underscore data set. And here I will pass Titanic. Here I'll pass Titanic. Now the name should exactly match with this name that you are having here. Okay. Now if I write here plt.show. Sorry. Data.head. Now this is the data set that we are having here. Now I don't think there is someone who don't know about Titanic. Those who has not heard about Titanic. You all know about Titanic, right? So this is the list of the passengers who were traveling in the Titanic. I'm not sure whether it is exactly correct or not, but this data set we have been provided. But we are not sure about this, whether this data is the actual data or not. I'm not sure about this, but this is the data set that we have. Okay. Now, what is this data set here? If you see, so many columns are there. Okay. So we have the survived column. Like it means whether a whether a passenger has survived or not in the Titanic. You must be knowing that there was an accident, right? So in that Titanic, when that Titanic was drawn, in that case, whether that passenger survived or not. So here 0 represents that died, he or she died, and 1 represents he or she survived. That's the meaning of 0 and 1. Okay. P class represents the passenger class, in which class he or she was traveling. So there are total 3 class here. If you want to check that, you can write here data dot p class dot unique. You can write here dot unique, and see here you got 3 values, 3, 1 and 2. So we are having total 3 class here, 3, 1 first class, second class, third class. Okay. Then we are having sex, then we are having age, then SIBSP stands for number of siblings and number of spouse traveling with the passenger. Siblings and spouse. Okay. Then Parch represents number of parents and number of children. That's the meaning of Parch. It's a fare. Embark is the place from where the passenger boarded the Titanic. So again, there are total 3 places in United Kingdom. Okay, you can check here. S, C, Q, and there is a NaN value also, so ignore this. So we have 3 places, S, C, and Q. S stands for Southampton, C stands for Cherbourg, and Q stands for Queenstown. The name of the embark station is given here, Embark Town. If you check this one, embark underscore town, you will get the name of that. See, Southampton, Cherbourg, and Queenstown. Okay. Then we have class, the same thing here, P class, it's same. Who, whether a man, woman, or children. Then adult male, whether he is a male, adult or not. Deck means the seat number, in which seat number he was traveling. Embark town, same thing. Alive, it's related to the survive column. So 0 means not alive and 1 means alive. Okay. And then whether he or she was alone or not. So this is about the data set that we are having here. Okay. So we will use this data set further also for the logistic regression. When we'll apply the machine learning algorithm. From tomorrow, we'll apply machine learning algorithm. Okay. So in that one also, I'm going to use this data set. Okay. Now, in this data set, I will apply the feature scaling and feature encoding. These 2 things I'm going to apply on this data set, and then we'll check what is we are getting here. Okay. So we have so many features here. All these are called features. And I'll explain more about the features in the coming class. What is feature and target here? Okay. True means you're talking about here. Here, true means that he is alone. He is not with family. So you can see here, both are 0. Both are 0 means he or she is alone. That's why it is true. Here we have 1. That means there is 1 sibling or spouse traveling with her or him. Okay. That's why it is false here. Okay. Fine. So now, first of all, let's understand the feature scaling. Now, how many technique I explained to you for the feature scaling? How many types? Huh. 2 type. 3 na, 3 na, 3, 3, 3. I explained standard scalar. I explained min max scalar, and one more I explained, which we use for generally for outliers. What was that? Robust scalar, if you remember, right? Standard scalar, min max scalar, and robust scalar. These 3 things I have discussed. So I'll take the example of these 3 things only. Okay. Now, So first of all, I'm going to tell you, acha, before that, let us create the subset. Okay, now look here. In this one, tell me first of all, for which feature we can take it as a scaling first. Like which one we can scale here? Which feature can be scaled here? What do you feel? Hmm. We can scale age, right? We can scale age, we can scale fear, we can scale what else? I think only these two only. Age and fear, right? Other thing we don't have any big values. They are very small, 0, 1 only. So we can scale age and we can scale fear. These two things we can scale. Okay. So what I'll do is I'll create a subset of this. So data, let me replace the data. So data of here I'll take let's say I'll take age first, then I'll take fair, and let's take sex also, because this I'll use for the feature encoding. This one I'll use for feature encoding. Okay. And what else we can use for feature encoding? Tell me. To convert the features, categorical features into numerical, which one we can use? One we have done for sex. Other one we can use for who? We can use for who also. But I'll take the example of let's say sex and embark. Let's say embark. Embark. Okay. Embark underscore. Let's take the example of these two, or I can take class also if you want class. Let's say class also. I'll take these three. I'll take these three. Okay. So these 5 columns I am taking right now. Okay. Now, if I write here data dot head, you get this. Got this. Okay. Now, whenever you go for scaling or whenever you go for encoding, remember one thing: there should not be any missing values in the data. There should not be any missing values. So if you see here, data dot is null dot sum. I've already covered all these things, so I don't think you have any problem in this. Okay, so in the age column, we have 177 null values. In the embark town, we have 2 null values. So for the age, what we can do, we can fill the null value for the age. Okay, but for the embark, we can drop it, we can remove it, because we have only 2 rows. Okay, so for the age, let's fill it. So data of age equal to data of age dot fill na, and here I will pass data of age dot, wait, let me calculate that separately. I am replacing with the mean of age. Okay, dot mean. So this is the mean. So let me round this value. So I'll write here np dot round. I will round this up to 2 decimals. Okay. And see, all these things I've already covered in our previous sessions. I'm not giving much time in this. Okay. Already covered this thing. Okay. So now I'll write here fill na mean of age. So my age part will be done. So now if I run this, my age missing values are removed now. Now I'll write here data is equal to data dot drop na to drop all the rows of that embark town. So now if I do this, Okay. Now you will not get any null value in your data. So all these things we have covered in our last session, how to deal with missing values in all these things. So if you have not attended that session, just go through that. I'm talking about day 4 and day 5. In day 4 and day 5, all these things are already discussed. So that's why I'm not giving much time in this. Okay. So now our data is not having any missing value, and now we'll apply scaling or encoding. So first of all, let's come to the scaling. Okay, so first of all, I will apply. Okay, already let me remove this. So first of all, I'll apply standard scalar. If you want to apply standard scalar, how can you apply this? So for this, we will use one library. Okay, we'll use one library for this. So the library is from sklearn dot preprocessing import standard scalar. Standard scalar. And now we'll make an object of this standard scalar. So I'll write here, let's say scalar equal to standard scalar. We've created an object. So we imported the library. Now tell me, standard scalar can be applied to which column? Can we apply standard scalar to embark, town, and class? And this sex also? These three can be applied to these three columns? No, right? We have to apply the scaling to only age and fair only. Only age and fair, not anything else. Only age and fair. So in that case, what I'll do is I will define one, let's say data underscore new, or let me take x. X is equal to data of age, comma, fair. Now on these two columns, I want to scale. So I'm taking this separately. Okay. Now x dot head will be this data. Now this data I want to scale. Now right now tell me what I told you about standard scalar, and what standard scalar does actually. Like after doing standard scalar, what will be the result of the data? If you remember the theory part, you can tell me. Tell me now. Mean to 0, standard deviation to 1. Yeah, that's very good. Basically, it makes sure that the mean of these two feature will be 0 and the standard deviation will be 1. It may not be exactly 0 and 1, but somewhat to 0 and 1. Okay. So let's right now check what is the mean of this and what is the standard deviation of these two. And for that, you all know we have a function which will give you both things, which is describe function, right? If I write here x dot describe, right now the mean is this one, 29.65, and here 32.09, and standard deviation is 12.96, and the fair is 49.69. This is right now. That means they are totally different from each other. They're not somewhat same. Okay. So now to normalize this, let's apply standard scalar. So I'll write here, let's say x underscore scaled. X underscore scaled will my scaled data equal to scalar. What is the scalar? Scalar is this one. Okay. Scalar dot fit underscore transform. Now this is the function which we use. Okay. Fit underscore transform. And here you will pass your x value. Now, if you print this x scaled, let's see, it will give you the data in the form of array. Okay. Not in the form of data frame. See, we got a 2-dimensional array. And now you can see the values are changed. It's changed. Now it's a scaled value. And now if you check this describe x scaled dot describe, okay, this will not work for this one because this is an array data. So what I'll do is I'll convert this into data frame and then I'll apply this. Okay, now look here. Now can you see the mean is minus 3.868297 into 10 to the power minus 17. Is it not a very low value? Is it not near to zero? It's 10 to the power minus 17. So it's a very small value near to zero. Okay. Same here also. Okay. And standard deviation, if you see, it is near to 1. Near to 1. Okay. So now they both are of almost same name. They are normalized now. So this is called scaling. And when I will go for the machine learning thing, I will practically show you the difference, what difference it will make in the machine learning, what accuracy, how accuracy is affected in the machine learning. This thing you will get to know in our machine learning session. When I will apply algorithm, you'll get to know that thing. This is how we apply standard scalar. So is that clear to everyone? Standard scalar is clear? Please confirm this. Okay, fine. Now, in case if I want to apply, this is a scaled data. This is a scaled data whose all the features he is having the mean value 0 and standard deviation 1. That is a normalized data. That's all. Because that is only the numeric column we have. That is only the numeric column we have now. Now, min max scalar. From sklearn.preprocessing import min max scalar. Yeah, fit transform is a function of this standard scalar that's used to normalize, that used to apply that scaling. Okay. Now here I will give the name of the variable as min max, and here I will call this function. Now one thing you have to understand in this one, that by default, it converts the value between 0 to 1, between 0 to 1. And if you see, we have one argument here. Let me, I'll hover the mouse, I'll get that. Not getting. Okay, see here. We have an argument here, feature range. In what range you want to convert? So by default, it is 0, 1. If you want to change that, let's say I want to change between 1 to 8. So you can write here 1 to 8. That's your call. Okay. So by default, it is 0, 1. So let's say I'll give here 0, 1 only. I want to convert the feature between 0 to 1. So I'll do this now. And now I'll apply this to my data. Let's see this. So X, let's say min max underscore scaled. So here I will pass min max dot same function fit transform, and let's see this now. So now this data will be between 0 to 1 only. If you check the describe function, you can see that. Now look here, minimum value 0, maximum value 1. So it's between 0 to 1 only. So this is how we apply min max scalar. Okay. So I hope Everything is clear? Good afternoon. It's evening here. Okay. I think you are in some other country. Okay. Fine. See, basically, I told that in the last session, standard scalar basically we use in almost 90% of the features, and min max scalar we generally use in the image data set where we have the range of the pixel between 0 to 255. So in that kind of data set, we generally use min max scalar, okay, to make it 0 to 1. Okay. Now, robust scalar basically we don't use much. But if you want to use robust scalar, simply write here robust scalar, everywhere robust scalar, and everything will be done. Same process. Same process. I'm not going to do that because we don't use much, because these two things are basically used. Okay. But if you want to use that from sklearn or preprocessing, import robust scalar, give here robust scalar, and simply you use fit transform to do the robust scalar also. That's all. Okay. Sikha, you can just scroll the video backward. You can take it backward and you can check it again. Okay. It's a live session. You can take it back. No problem. Okay. Fine. So that's how we do this scaling. Okay. So feature scaling is completed. Now let me tell you about the feature encoding. Okay. Now feature encoding will apply to these three columns: sex, embark, town, and class. Okay. So let me separate the data again. So let me take y variable. Y is equal to data of x. What else we are having? Embark underscore town, and the third one was uh, class. Okay. Okay. Now here we are having three feature which is in categorical form, and I want to convert this into numeric value. And I explained about two types of data: nominal data, ordinal data. Nominal data is that kind of data which is, what is nominal data? Tell me. I explained that in the last session. What is nominal data called? No order. Yes. Nominal data is that kind of data which is having not no order, no rank. So out of these three, can you tell me which data is nominal and which data is not nominal? Let me write in comment. Yeah. Which data is nominal and which data is not, which ordinal. Like what is the sex data? Tell me. Is it nominal or ordinal? Yeah, only class is ordinal and these two are nominal. That's correct. Very good. So this is also nominal and this one is ordinal. Correct. So I hope you all agree to this, right? So for the nominal data, what is the technique that we use for the nominal data? What's that technique called that we apply for the encoding for the nominal data? Yes, very good. One hot encoding. One hot encoding. So let's apply this and let's understand how to apply one hot encoding. Now, one hot encoding can be applied by two ways. I already explained that, either using pandas dummies function or using the scikit-learn library also. Okay. So first of all, I'm going to tell you with the help of pandas, using pandas. Now, so let's say I'll take a variable gender is equal to. Now I want to create dummy variable for the sex column. So tell me how many dummy variables will be created if I go for this column. How many dummy variables will be created? Tell me. How many dummy variables will be created? One, two dummy variables, because we have two things, male, female. So there will be two dummy variables. So I'll write here pd dot get underscore dummies, get underscore dummies, and here you will pass the column that is y of 6. Okay. Now if you print this gender, you will get two dummy variables. See, we got one female and we got one male. And here 0 represents that the passenger is not female. 1 represents that the passenger is male here. So here it is 1, here it is 0. It means this is female, not male. Now, as I told you in the last session, when we create dummy variable, we delete one column, right? We delete one column. So one of these two columns we will drop. So there is one inbuilt function here. We can write here drop underscore first. Drop underscore first is equal to true. That means it will drop the first column. That means this one. So now if I do this, look here. Now we are getting only one column, male. Now here 1 represents the person is male, 0 represents female, right? Tell me, am I correct? 1 represents male, 0 represents female. So this is the one hot encoding using the pandas dummy function. So am I clear to this, everyone? Is that thing clear? Yeah, we use only one variable, that you are correct, but initially there are two dummy variable which is created. Okay, fine. Similarly, I will apply this to the embark town also. So let me do it for embark town also. So let's say embark is equal to pd dot get underscore dummies, and here I will pass embark underscore town, and here also I'll drop the first column and your data will be this. Okay, you can see here. So now we got two variables, Queenstown and Southampton. Now if this is 0, if this is 1, Southampton, if both are 0, what is both 0 represents? Both 0 means what? Cherbourg, right? Both 0 means Cherbourg. Okay. Can we then generate one variable? I'm not getting your question, Mamta. So here we have created our dummy variable for the gender also and for the embark also. So our one hot encoding is done for the data. So this is using pandas. Okay. After some time, I'll tell you using the scikit-learn also. Now we have generated this. Now tell me what is the next step we should do in this. We generated it. Now what should be the next step? Tell me. What should be the next step now? We have to add this. We have to add this to our data, right? Let's say this is my data. So we have to concatenate. Yes, correct. Concatenate this to my data, this one. So how to concatenate? To concatenate, simply I can write here pd dot concat. Pd dot concat, that stands for concatenate. And here in the list pass here, I want to concatenate data with gender with embark. And don't forget to write here x is equal to 1. That means we are concatenating as a column. Okay. And now if I run this, now you can see that we have our data here. Now see here, if you print data dot head, all we are it is not modifying our original data. So don't forget to write here data is equal to this. Okay. So now we are having these 3 columns with the encoded feature, and now you can delete these 2 columns, and that you already know how to delete that. So you can delete that if you don't want that. That's done. Okay. If there are 3, then also it is correct. Now, Akhil, if there are 3 columns also, let's say all the 3 columns are 0. That means the output is the 4th column only. That's all. If all the 3 are 0, obviously it belongs to the 4th one. Okay. Fine. So now coming to the next thing, how to do the one hot encoding using scikit-learn. Using scikit-learn. So from sklearn dot pre-processing import one hot encoder. One hot encoder. And we'll make an object of this. Let's say OHE is equal to one hot encoder. We created an object of this one hot encoder. Okay. Now we'll apply this to the data. Now the data that you want to apply, you can apply this to same embark or gender. So let me apply this to gender. So let's say I'll write here gender variable equal to OHE dot fit underscore transform. Fit underscore transform. And here you will simply pass the column that you want to do. So y of embark, sorry, gender, no? Y of sex. Y of sex. Now, one thing, when you run this code, look here. You'll get an error here. Reshaping your data using reshape -1 if your data has single feature or array.reshape. That means it's simply saying that you have to pass a 2-dimensional data, not a single dimension data. That means you have to take it in the form of double square bracket. Just remember this thing. Okay. Now if I run this and if I print this gender, let's see what we are getting here. We'll get an object like this. So now to convert this to our actual data, we can write here gender 2 dot 2 underscore array. And you will get the data in the form of, sorry, not underscore. Underscore is not there. 2 array. And see, we got the data in the form of array. 2 columns we are having. And now you can convert that into data frame also and concatenate in your column. So pd dot data frame, and you can write like this, and see, we got the data here. So we are having two columns here, against two columns. And what to do now? How many columns we require finally for the gender? Only one, right? So we have to drop one. So I'll write here gender dot drop, and here I'll pass the column name 0. I want to drop 0 column, and axis equal to 1, and then this is my final gender. See, now you got it. So in this process, in the OHE process, first of all, you have to import this OHE library. We have to transform this, convert this, then we have to convert to array, then we have to convert to data frame, then we have to drop, and then we can concatenate. So is it not a lengthy task here as compared to dummies? Tell me, what do you feel? Which one is more easier? Tell me. Which one is more easier for you? Dummies one or this one? Actually, both are easier, but in this one, we have some extra steps. We have to drop it separately. In that one, we can do it in a single line. Here, we have to convert to array. We have to convert to data frame. All the things we have to do here. So it depends on you what you want to choose. You can choose any step, okay? Either you use scikit-learn or you use pandas dummies. Both are same, okay? But the process, the way of doing this is something different, so that you have to choose what you want to take. So this is how we apply one hot encoding. So I hope everyone is clear, right? Now coming to the next part, which is your, what are the next step? Label encoding, which is for the ordinal data. Already I have covered in the last session. X is equal to 1 means we are dropping column. 1 represents columns. Okay. Because in the nominal data, we cannot do that thing. Okay. You cannot do that thing because that is not a correct way. You can do that, but that is not correct. In ordinal data, you have to use like this only. But now what we are going to do, ordinal, in the ordinal data, whatever you are saying, that is a part of ordinal data. That you can do for the ordinal data, not for the nominal one. Okay. So now I'm going to tell you how to apply label encoding for the ordinal data. Now in the ordinal data, if you remember, I told you that according to the rank, you have to provide the number. Let's say there is a 3 feature A, B, and C. Now A is having the higher rank. So you will apply value 3 to A, B to 2, and C to 1. So same label encoding can also be done by 2 ways. So first of all, I'm going to tell you one way using pandas. Okay. Using pandas, how can you do this? So, okay. So I want to apply this for the, which column? I forgot that. Which column we have to apply this? Class. So now we have 3 class here. We have third, we have first, we have second. Now tell me which one should be applied as the feature 1, then 2, then 3. Which is having the highest rank here? Tell me, which is the highest rank here? Which is having the highest rank? Which one is having the highest rank? First one, right? Obviously the first class. First class is the rank 1. So if the first class is the rank 1, so if I am taking the value, let's say 1, 2, 3, so I'll assign 3 value for the first. And if I'm taking 0, 1, 2, I'll assign 2 to the first. The higher value will be applied to the first rank one. Okay, so for doing that, equal to this dot map. Now we have to use here a map function. Map. Okay, map. Now let me do one thing. Class underscore new. Okay, let me show you one thing here. In map, you have to be very much careful. Very much careful you have to be in the map. Now what that careful thing let me tell you. Let's say in the map, I'll create a dictionary, and I hope you all remember dictionary. So I'll create a dictionary here. And in the dictionary, first of all, I'll go for the first class. So for the first class, I will assign the value as 3. As I told you, first rank, higher value. Then second class, I'll assign the value as 2. And third class, I will assign the value as 1. So if you are taking 0, 1, 2, right here 0, 1, and 2. That's your call. Okay. So now like this, you do the label encoding. So here you can pass your own choice value. Whatever you want, you can pass here. Okay. Now if I print this data dot head. Now look here, class new 1 for the third. For the first, we are having 3. For the third, we are having 1. Now, why I told you that you should be very careful in this. Now see, if I write here F in small letter. Now tell me, do we have any class with this name in our data? As I told you, Python is case sensitive. So do we have any class like this? No, right? We don't have any class with this column, right? So in case if you do this mistake, if you do this kind of mistake, let me run the code and show that to you. See what is happening here. We defined for second is fine, third is also working fine, but we haven't defined the value for the first class, so it has converted that value to nan. Look here. So if you don't pass any label for any class which is present here, it will assign the value as a null value, as a nan value. That's why I told you, you have to be careful in this thing. So I have to write here F capital and then it will work fine. And now it is okay. Okay, so be careful about this thing. So this is one way of doing the label encoding using pandas. Now, the same thing if you are going to using scikit-learn, now there will be some different way. In that way, there is something different. I'll tell you what is that different in that way. Let me do one thing. Okay, now you are having 3 class right now. Third class, second class, and first class. Now tell me, if I tell you to arrange this in ascending order, in alphabetical order, what will be the order for that? I want to arrange this in alphabetical order. So which will be coming first in this case? Third, second, or first? In alphabetical order, what will be the order in this case? Yeah, first of all, we will have first, then we will have second, and then we will have third. Am I right? Tell me everyone. First, second, and third. This will be the sequence. Am I correct? Alphabetically order. So if you are going to use scikit-learn library for doing the label encoding, in that case, it will assign this value as 0, this value as 1 and this value as 2. The scikit-learn library are assign the labels in the alphabetical order, in the ascending order. So 0 will be assigned to the first letter, then 1, then 2, then 3, then 4, and so on. So 0 and 2. So F will be assigned as 0, S will be assigned as 1, and T will be assigned as 2. So do remember this thing. So in most of the case, we prefer to use map function, because in map, we can give our own value according to our requirement. We know which is having the highest rank. We know that thing. So in that case, we can apply our own value. But in case if you want to apply using the library, I'll tell you how to do that. So for that, from sklearn dot preprocessing import label encoder. So let's say LE is equal to label encoder, and here I'll now write data of, let's say, class underscore label is equal to LE dot fit underscore transform. See, the function name is same for all, fit underscore transform, and here you will pass data of class. Okay, now if you see data dot head, look at here. What is the problem? Oh, sorry, my mistake. Okay, look here, same thing we got here, but for the third it has assigned the value 2, for the first it has assigned the value 0, and for second it has assigned the value 1. So it is done in the alphabetical order. Okay. So am I clear about this feature scaling and feature encoding? This is all about the feature scaling and feature encoding. Am I clear to all? And everyone present here, please click on the like button. Hit the like button, all of you. Make it 100 now. Hit the like button, all of you present here. Okay. Yeah, we can do that also. You can apply label encoding to the embark also. But as I told you, that is the nominal data. So we don't do for that. Okay. But you can do that for that also. It's not it will not give you error that we cannot do for that. Okay. Yes, it is case sensitive. Yes. Dummy variable is very simple. See, if you call dummy variable, if you are having two features in this, let's say male and female, it will create two different column. That's all. And this, it will, after creating two different column, what we are doing, we are dropping the first column. That's all. Fit underscore transform is simply applying whatever thing we want to apply. If I have imported label encoder, it is going to apply label encoding. If I am using for one hot encoding, it will apply one hot encoding. So whatever thing that you want to apply, that is what that doing here. That transformation, that conversion, scaling, encoding is done by this one. Okay. Darshan, see, those who want to repeat this, just simply move the video backward and you can just repeat that thing again. You can take it backward. Or just go through the recording again, okay, after the session. And in case if you are again don't understand the topic, just tell me tomorrow, I'll explain that again, okay? Okay. So I hope scaling and encoding is clear. Now moving on to the outlier. Now for the outlier, listen, I explained that in the last session that encoding is done because we cannot apply mathematical operation in this data. In the machine learning, we have to apply encoding, mathematical operation. We cannot apply mathematical operation to this. We cannot apply mathematical operation to this. We need a numeric data for that. That's why we have to do encoding. And scaling is done for the normalization so that the data should be normalized. All the features should look same. If the data will be different from each other, machine learning will give priority, different priority to all the features. That's a need of scaling. And you'll see the importance of scaling in the machine learning algorithm part also. I'll show you there also. So without feature scaling, how much accuracy you are getting, and if I'm doing feature scaling, how much accuracy you are getting, you will get to know in the coming class. Okay. Now let's talk about outliers. Now, for this outlier, I will randomly create one sample. Sorry. I'll create some data here randomly. Okay. Library is already imported. So let's say data is equal to, and let's say I'll take a list here 11, 12, 13, 14, 11, 21, 22, 11. Okay, now in this complete data, tell me what are the outliers value? What is the outlier value in this complete data? Tell me. Yes, we have 150, we have 190, and we have one more I have taken. Where is that value gone? 150, 190, and 102. So I am assuming that these three are the outliers. So we know that thing, but let's find out using the techniques. Let's figure out this value. Let's find out this value using the techniques. I told you about 3, 4 techniques in the last session, if you remember. Can anyone tell me the name of all these techniques? The first one was using scatter plot. Second one was using box plot. These are in the form of visualization. The third one was using what? Z-score, correct. So in Z-score, what value we consider as an outlier? Which value will consider as an outlier? Greater than 3. Greater than 3. And the fourth one is your IQR, that is interquantile range. So these are the 4 different way for finding the outliers. Okay. So how to use all these way? So first of all, let me tell you about the scatter plot. Now scatter plot already we have done in the last some session. How to plot this? PLT dot scatter. Now tell me, what should I pass as an X value here? As an X value, what can I pass here? Tell me. Not required. How not required? Scatter plot requires two things, X and Y value. Can we plot using only Y? See, sorry, I'll pass here data. Wait. If I pass here data, it will give you the error. One, we require two things, na? If I have to plot a scatter plot graph, we require X and Y both. So Y is your data. That's correct. Y is your data. But what will be the X here? X will be actually 1, 2, 3, 4, 5 like that, right? Basically, can I say that this is 0, then 1, then 2, then 3, then 4, then 5? Can I say like this? Tell me. So I can write here one thing. If I write here, if I use a range function, and in this one, if I pass length of data, what would be the value in the range now? 0 to 86, the length, whatever length we have. So I can pass this one as an X value, 0 to 86. I can pass this as an X value. Okay. And now if you write PLT dot show. Okay, look here now. This is my scatter plot. And I can see these 3 points are clearly looking like outlier. Am I right? And most of the data set samples are here. And these 3 points are considered as an outlier. You can see that clearly. Okay. I can simply write one condition that drop all the data where the value is greater than, let's say, 80. I'll write one condition that remove everything where the data is greater than 80. I can do that simply. Using pandas, you can simply filter out that data. Okay. So this is one way using scatter plot. Okay. Now, second way is your box plot. Let's come to the box plot now. So now BLT dot box plot. Now in this one, you just have to pass a single column. That is X equal to data. That's all. And PLT dot show. Okay, now look here, we got this box plot. Now, it's very small if you see at the bottom. I explained in the last class, if you remember, what is this bottom line represents here? What is this bottom line represents here? This bottom black line, the small line. It's a lower value, right? Then 25 percentile, then 50 percentile, then 75 percentile, and then maximum value. So I told you whatever value you are having before this line or after this line, that will be treated as an outlier. If you remember, I told you that thing. That will simply give you a warning if you don't do that, okay? That will not give you error. So to ignore that warning, I have written here X equal to data. Okay, so I can clearly see that these 3 points are my outlier. Okay, so box plot and scatter plot done. Clear? So I hope it's clear, everyone. Now coming to the next thing, that is using Z score. Using Z score. Now using Z score. Now, do you remember the formula for the Z score? Explained that in the previous session. It is x minus x minus, tell me, x of mean, correct? X of mean and divide by standard deviation. Very good. Standard deviation. So this formula we are going to apply and calculate the Z score for our each sample, for the each data. Okay. So what I'll do is I will take a blank list here where I'll store all my outliers. I'll take a blank list and I'll make a function. Let's say detect underscore outlier. Now I hope you remember this def keyword. What is the meaning of this def keyword here? Hmm? Yeah, we are creating a function and here I am taking one argument. Here I will pass my data which from where I want to calculate my outliers. So this data is not that data which we have taken here. This is just a variable name here. I'll do one thing. I'll take here X so that you don't confuse. Okay. I'll take here X. So now what is the Z score threshold value that we take to detect outlier that I explained in the last class? What is the threshold value of Z which we use for as a threshold for the Z value? 3. Yeah, very good. So I'll write here threshold equal to 3. Let's say threshold is equal to 3. I've defined here. Now I'll calculate the mean of my data. So I'll write here np dot mean and I'll pass here X. The data that I'm passing here, X here. Okay. So it will calculate the mean of your data. Similarly, you calculate the standard deviation of your data. So np dot stt and pass here X. So we calculated mean, we calculated standard deviation. Now one by one we will go to each sample and calculate. So for I in X. Now I hope you know the meaning of this loop. For I in X means one by one I am taking each sample of X inside this I, right? So now I will calculate Z score here. So Z underscore score is equal to, now tell me what formula should I write here? Now let me see how many of you are saying this correct. What should I write here as a formula? Z score is equal to what? Yeah, very good. I minus mean divide by STD. Yeah, very good. No, not X. I. X is your complete data. We have to take one by one each sample. Na? So that will be I. Okay. So one by one we are calculating the Z score for each sample. Okay. Now we'll check for each sample. Now this Z score can be negative also, as I told you. It varies between -3 also and 3 also. So what I'll do is I will take the absolute of this. So I can write here if np dot absolute of Z underscore score, I'll simply take an absolute, is greater than threshold. See, if you don't calculate Z score, then you have, sorry, if you don't calculate absolute, you have to check for two conditions. Either it is greater than 3 or it is less than -3. So instead of checking for two conditions, I am converting into one condition only. That if the absolute value of Z score is greater than threshold, so what you will consider that value? As an outlier. So I'll write here outliers dot append I. I'll store that in the outlier. And finally, outside the for loop, I will write here return outliers. So I'm making a return function. Return outliers. So now if I run this, done. Now we'll call this function. So let's say my underscore outlier is equal to, I'll call this function and I'll pass my data here. And let's say what data we are finding here. Okay, you can see here we got that 3 points only, 102, 150 and 190. We got these 3 points only. So we got the outliers using Z score. Am I clear? Tell me. All of you, please hit the like button watching this session. And please subscribe to my channel if you have not done yet. Okay, so am I clear? X is simply a variable for the function. It is simply an argument. Okay, it's simply an argument. That means whenever we are calling this function, we are passing here data. So now this data will be stored inside this X. Okay. No, Girish, you don't have to apply all the techniques. You can go for any one or two technique. But I will prefer that you check for all the technique whether you are receiving the same output from all or not. But Z score and whatever I'm going to tell you the next IQR, these are the best one. So you can go for that. Okay. Threshold 3 I explained in the last session that in the Z score formula we consider the value as outlier where the Z score value is greater than 3. So Z score greater than 3 is considered as an outlier. I explained that in the last session. It is fixed. Yes, it is fixed. Okay. So now coming to the next, which is your IQR. Threshold for X value, sorry, Z value. For Z we are taking threshold to calculate outliers. No, email data set. No, we do it for the feature. For the email data set, generally we don't get the problem of outliers. Generally in the values where we have a value, there we get a problem of outliers. In the email data set, there is no problem of outliers. Okay, that's not a problem there. Now tell me everyone, I hope you remember the process of calculating the outlier using IQR. What is the first thing that we require in this? The data should be in which order? In a sorted order, right? It should be a sorted data, right? So let us sort the data. I'll write here data is equal to sorted. Sorted is an inbuilt function in Python. So I can write here sorted data. And this is my sorted data now. So look here, we got the sorted data now. It's a sorted data, see. Okay. Now from this one, we'll find out our outlier. Okay. So if you remember the step of the IQR, after getting the sorted data, what is the next step? We have to calculate what? We have to calculate the, tell me, what we have to calculate first? Q1 and Q3. Very good. Q1 and Q3. That means quantile 1 and quantile 3. So I will write here quantile 1, comma. You can take Q1 also. Let's take Q1 also. In short, Q1, comma Q3. You can take any variable name. That's a simple variable name only. So I will write here np dot percentile. Now here in the numpy we have a function percentile. In the and percentile I will pass my data which I want to apply. Simply I will pass my data. Now which percentile I want to calculate? So quarter 1 is for how much percentile? Quarter 1 is for how much percentile? 25. And quarter 3 is for 75. So it is going to return two value, one for 25 percentile and another for 75 percentile. So if I print Q1, comma Q3. So look here, this is my 25 percentile, which is 11.0, and 18.0 is my third percentile, which is 75 percentile. Okay, so we got this Q1 and Q3. Now tell me the next step. We got Q1 and Q3. What is the next step now? Sort data. Yes, IQR, correct. Calculate Q1 and Q3. Now the IQR should be calculated. So calculate IQR. So IQR is equal to, what is the formula for IQR? Q3 minus Q1, and your IQR is 7. This is your IQR. Okay, so we got the IQR also. Now find the lower and upper bound. Find the lower bound and upper bound value. The lower value which is from below, which will be considered as outlier. Same thing for the upper value also. So first of all, we'll calculate the lower value. Lower bound value. So what is the lower bound value formula? That is also explained in the last class. Tell me. Yes, Q1 minus. It's very good to know that you all remember this. 1.5 times of IQR. Very good. IQR. And then upper bound value is Q3 plus 1.5 multiplied with IQR. Okay. That's all. That's all. So now we'll let me print these two value. Print lower bound value and print upper bound value. Okay, done. So now what you have to do is whatever data you are having below this value or greater than this value will be considered as an outlier. So if you check data, let me do one thing. PD dot data data frame, and here if I pass data, I'm converting into data frame so that I can apply the filter easily. Okay, now here I'm having this. So now if I want, let's say I'll store this into the df. I'll store this inside the df. Okay, now this is my lower bound, this is my upper bound. So I can write here df of data less than, df of 0 na, the name of the column is 0. Okay, so I'll take here 0, df of 0 less than 0.5. Wait, let me rename the column. I think this 0 is giving problem here. Wait, I'll write here df is equal to df dot rename. I'll rename the columns equal to 0. I'll rename this to, let's say, samples. Okay. Okay, now it is fine. I'll pass here df of samples less than 0.5. Okay, so it is giving you false, false, false everywhere. So if I write here df of this is just a filter which I explained in the pandas. Okay, so we are not having any row. We are not having any row. But if you check for greater than what are the higher bound value? Let me write here instead of 0.5, I'll write here lower bound value, and here I will pass upper bound value. Okay, so these three samples we got here also. So you have to drop these three. So that's how you find out the outliers using 4 technique: scatter plot, box plot, jet score, and IQR. That's all. So have you all understood? No. You don't have to write single quote 0. Single quote 0 will not be applicable in terms of the numeric data, numeric column name. So I hope you all understood this. Please tell me. Yeah. So that is all for this. And now we will be applying machine learning algorithm. But before going to the algorithm, I have to tell you something about machine learning, types of machine learning, and all these things I have to tell you. So let me tell you now today. So open my this. Just give me a minute. See, Girish, for multiple column, you have to go column by column only, one by one only, not with all the data. Okay. Yeah, why not? It will work in every case. But you should try with all the values. See, let's say you want to check the outlier. Wait. Okay. I want to check the outlier, let's say in the age column. I want to check it in the age column. So let's say I want to use the Z score method. Okay. I want to use the Z score method. I'll simply pass here data of age. See, these are the outliers in the age column. That's done. Okay. So like this you have to do. Yeah, you have to write that in the loop. In the loop, you can write that. And that is the role of a feature like a data analyst in the machine learning field. There is a specified person who does all these work, feature cleaning, feature engineering, all this done by a single person. They hire a different person for doing only this thing. Okay. Fine. So now let's understand the machine learning part. Why it is coming like this? Just a minute. Okay. In feature scaling, why do we mean to normalize the data? That's the meaning of normalization, so that they all look almost same. That's the meaning of normalization. Now, first of all, what is machine learning? Can anybody tell me the definition of machine learning? Whatever you know. Anyone? Yes, you have to remove those outliers. Yes. Giving data to model, train model to predict output. Yeah, basically here we train the machine with some data. We train the machine with some data. So basically it simply means that you are using some data to train a machine, and according to the training that you have applied to the machine, he will do some sort of prediction. Like right now I am giving training to you all, right? So if you are understanding the thing properly, if I'll take a test, you will definitely score good marks if you understood everything clear, and that means the training is good. So let's take an example that you have a data in the form of x and y, let's say, where y is my output and x is my input. So let's say you have 1 2 3 4 and 5, and here let's say we have 20, um, 40, 60, 80, 100. Now this is the data that I'm having right now. Now I am using this data to train my machine. So when the machine will be trained using this data, the machine will completely analyze this data, and he will find out some sort of formula, some sort of relation between x and y. So what is the relation that you will get here in between x and y? What is the relation that you will get here in between x and y? It will simply, can I say 20 of x? Tell me. Can I say that we will get y equal to 20 of x? Right? So that's the relation that we got here. So now after this training is completely done, if I ask the machine, hey, tell me the value for y for x equal to, let's say, 10. X equal to 10. So what machine will give you? Machine will simply give you 200. Because he has been trained like this only. He has been trained like this only. So according to the data that you have used for the training, the machine is going to predict something. And that is simply called machine learning. So I hope the machine learning is clear. What is machine learning? That is clear to everyone. Okay. That's a typing mistake. It's a quartile. Correct. Quartile. Yes. Okay. Thank you for correcting that. So that's the machine learning. Now let's discuss what are the different types of machine learning. What are the different types of machine learning? The first one is supervised, second one is unsupervised, and the third one is reinforcement. So these are the three types of machine learning that we have. Three types of machine learning. Okay. So I'll tell you in short about these three. What are these three types of machine learning? The first of all, we'll come to the supervised machine learning. Supervised machine learning is that type of machine learning which you apply to the labeled data. So the training applied to the labeled data. Now, what is labeled data? Labeled data is that data, you can call it as unknown data, or I can call it as whose output is known to you. The output is known to you. You know the output of that. Like the previous example that I have taken here. Here I know the y value. I know about this y. So this is called supervised learning. So there is a supervisor. There is a supervisor in which, like right now, I am training you. I am the supervisor right now. You are following my training. So that is called supervised learning. Right now, whatever I am doing right now, this is called supervised learning. So here you have a known data. The y value is known to you. You know the value of y. So if you are applying the training to the labeled data or known data, that is simply called supervised learning. Now, in supervised learning, we have two types of technique. One is your regression, and one is your classification. Regression and classification. Now, regression is that kind of technique, that kind of problem statement where you predict a real value. Real value means numeric value. Let's say I want to predict the age of a person. I want to predict the salary of an employee. I want to predict the cost of a house. So cost of house, age of person, okay, salary, okay. What else we can have? There can be so many things, okay. So if you are predicting a real value, if you are predicting a numeric value, then that type of problem statement is known as regression problem statement. And if you are predicting a class, predicting a class means let's say you are predicting cancer, no cancer, whether a patient is having cancer or no cancer. So there are only two results here, either cancer, either no cancer, okay. Or you are predicting, let's say there are three class: cat, dog, lion. Whether the image is of cat, whether the image is of dog, whether the image is of lion. So this is a classification problem. So we can have two class, we can have more than two class. So if you are having only two class, then that kind of classification is known as binary classification, like male, female, 0, 1, true, false, yes, no. All these are the example of two class. And this is the example of multi classification. where you have more than two class. More than two class. So whenever we have more than two class, in that case, we predict the probability. Okay. We calculate the probability. I think the spelling is wrong. Okay. Probability. If the probability of lion is higher, I can say that the output is lion. If the probability of cat is higher, I can say that the output is cat. So this is the type of supervised learning. So either we have regression or we have classification. Now for regression, we have so many algorithms, like we have linear regression, we have decision tree regression, we have k-neighbor regression, we have random forest regression, we have so many types of regression, support vector machine. Similarly, for the classification also, we have logistic, k-neighbor classifier, decision tree classifier, random forest classifier. So there are so many algorithms that we can use for this. And it's not like that you have to know all the algorithms. If you know one or two or three, that is also fine. Okay. So we'll understand in the next session how to apply these algorithms and how these algorithms work, which we'll explain that later on. But this is the type of supervised learning. Now coming to the unsupervised learning. Unsupervised learning is that kind of learning where training is applied to the unlabeled data. Unlabeled data means not known. Output is not known to you. The output is not known. We don't know the output. Hasina, I told that in the group that I'll continue till 9 o'clock for this complete week. Output is not known. Okay. So here y value is unknown. You have only x. So here we have a concept of clustering. Now what is this clustering? Clustering means here you create different cluster based on similarities. Based on the similarities. It may be based on color, it may be based on size, it may be based on some other property. So based on the similarities, we divide the data into different clusters. And then we do the prediction. That is called unsupervised learning. So based on similarity, we divide the data into different clusters. Like you can take a data set with unknown images. You downloaded so many images from the Google and you don't know who is the person in that image. You downloaded so many audio files and you don't know who is the person speaking in that audio file. So based on the similarities, you group the data. And that is called cluster. Then the last one is reinforcement. Now, what is reinforcement learning? Anyone? What is reinforcement learning? It's lagging. Yeah. Learning by experience. Here the machine learns by experience instead of training. So here we don't train the machine. The machine learns itself by experience. Yeah, it's a reward and penalty based learning. Yes, it is also called also called reward and punishment based learning. Correct. Punishment or penalty based learning. So for doing something, you either get a reward or a punishment. So all the AI related games that you play, like Ludo, chess, all these things are the example of reinforcement learning. Chess is the best example. Like we learn chess by experience, right? No one can make us perfect in chess by just giving us the training. We learn chess by experience. By experience, we learn the chess, right? So by playing it again and again. This is called reinforcement learning. So I hope the types of machine learning is clear to everyone. Yeah, these three types are clear. Now the last thing in this theory part. Now this is very important. Please understand and remember this for the upcoming session. Flow of machine learning. When you are going to apply machine learning, what should be the flow? What should be the flow? In what steps? How you have to proceed? That we are going to understand. Okay. Now, everyone, please like the session. Hit the like button, all of you present here. Okay. Uh, 3 days basically. 3 days. Okay. Now, what is the flow of this? In the first step, first of all, we have a data. Now, this data is your cleaned data. Just remember this. This is your cleaned data that we have cleaned using so many techniques that we have already learned in the previous session, like using pandas, all this feature engineering, feature encoding, all these things you have done, outliers, everything you have done. It's a cleaned data. It's a proper data now. Now, in this data, what you are going to do first? First of all, we split the data. We split the data into two parts. Now, what is splitting of data? Split the data into two parts. One is your training sample and another one is your testing samples. Okay. Sound cut ho raha hai? I don't think so. I think there's a problem of a network in your side. Please check, Prakash. So training and testing. Now, training samples are those samples which you use for the training purpose. And testing samples are those samples which you use for the testing purpose to evaluate your model. Okay. Let's say, I'll give you an example. Let's say you have 100 samples. Now just tell me one thing. If I will use all the 100 samples for the training and during the testing, if I am passing some samples from the same 100 samples only, can we properly evaluate the model in that case? Whatever accuracy you will be getting in that model, can you say that it is perfectly correct? No, right? That means you are actually biasing. Yeah, you are actually giving the known data to the model. So if the model will get the known data, obviously he's going to get the good accuracy. So we don't pass the complete sample. We keep some sample for the testing. And generally we use 80% and 20%. That's a general ratio. And it's not a rule that you have to go for 80-20 only. If you have large number of samples, go for 90-10. If you have less number of samples, go for 80-10, 75-25. So that can be any ratio. But we have to make sure that we give more samples for the training. Okay. Now, after the splitting is done, we model selection. Then you select which model would be appropriate for our data. Let's say, no, that is validation is different thing. Validation is that I'll discuss in the coming session. Validation is different. We have a different types of cross validation. That is also a part of splitting of data only. Okay, but that is different thing. That is a part of model to improve the model performance. Okay. Now, model selection means you choose the model according to the sample that you are. Let's say you want to predict for 0 and 1. So which model would be appropriate? You want to predict a real value. So which model would be appropriate? So for that, you have to choose the model. Tomorrow, I'll tell you some different models which you can use for the different data set. Okay, so you decide which model would be appropriate for our data. Let's say if I give you a problem statement of maths, you will first of all find out the formula, that which formula would be applicable to this, and then you apply that formula, right? Same thing here. After choosing the model, we build the model. We call the model and we make the model ready. We make the model ready. After building the model, you train the model. You perform the training. You perform the fitting of the model, training of the model. And after the training is done, we will predict the output for the testing samples. Using the testing samples. Now see, in the test sample also we will have X and Y, right? If I am using supervised learning. So in the testing sample also I am having X, I am having Y. So in the prediction, will you pass both X and Y both? Tell me. Let's say you have this. You will pass only X. Only X will be passed. And model will give you Y. That Y which model will give you, that will be compared from here. That will be compared from here. You will compare that. Okay. And if the comparison is okay, if there is no big error, we can say that the model is good. So after the prediction, you evaluate the model. So there are some different matrices. There are some different formulas to evaluate the model, which we will see in the algorithm part. Like for regression, we have so many different things. For classification, we have different things that we'll see in the next class. So if we'll evaluate, we'll calculate the error. This simply means error and accuracy calculation. Error and accuracy calculation. Okay. We'll calculate all these things. If it is fine, if you are getting less error, if you are getting good accuracy, then straight away you can go for what? You can go for model deployment. Model deployment so that it is now available to the normal user also. Normal user can also test this now. You can create the web application and you can go for deployment. So these are some different steps that you have to cover. And one more thing, if you are not getting the good evaluation, you may have to go to the previous step and you have to check it again. Maybe you are not passing a very clean data. Maybe the data is not good. Maybe you have chosen the wrong model. So you have to go back and repeat the process again. So this is the flow of machine learning. Okay, that's the flow. So I hope it's clear to everyone. So today we studied the types of machine learning, what is machine learning, all these things we have done, then flow. And in the next class, I will explain about the linear regression algorithm. And in that algorithm, I'll tell you how to apply this to the data set. So tomorrow we'll apply the algorithm. Okay. So that is all for the today's session. Now, all of you present here, please hit the like button and subscribe to my channel if you have not done. Please do that thing for me. Okay. No, no, no. Flow means the way of movement, how you have to proceed to apply machine learning. An algorithm is the process. That's different thing. Okay. Yeah, yeah, I'll provide that in just wait. Okay. There is a very high scope of machine learning in the job. Right now, it is in the top five. Machine learning, Python, and all everything. Uh, which this one, I'll share this on the in the drive. I'll upload this thing. I hope you are having the drive link, na? In the WhatsApp group, I have shared one drive link on Friday or Saturday, I guess. And in the WhatsApp description, also the drive link is there. Okay. So in the same drive, I'll upload these files today also. You can get it from there. Okay. After some time, I'll do that. Okay. Yes. So now I'm giving you the attendance link. So you can go and fill the attendance and you can come back after filling the form and tell me if you have any doubts. So before going to the attendance, everyone please hit the like button. 159 participants are there. Make it 150 at least. All of you hit the like button. Those who have not done, please do it. This is only one support that I want from your side. Okay, take the attendance link I have given on the chat. That we'll understand tomorrow, Srikala. Okay. That is a part of cross validation that we'll understand. If I'll get time, I'll cover that thing also. Okay, Harendra? If I'll get time, I'll cover that thing also. That is a part of cross validation, where we split the data into validation, training, and testing. Attendance link is provided on the chat. You can go through that. Okay, I'll see that, Harendra, no problem. Sangeeta, you will get to explain. See, tomorrow, if let's say if I cover linear regression. So explain algorithm means you have to explain how linear regression work. That's the meaning of explain algorithm. That working of algorithm, working of any algorithm that you are using. That's the meaning of explain algorithm. Okay. Yeah, thank you so much, Ritu. So all of you go and fill the form first and then come back and ask your doubts. Okay. Meanwhile, I'll upload this to the drive. Okay, okay. Thank you so much. Thank you so much. Okay. So make sure that you practice everything that we have done till now. Okay. Thank you so much, Kevin. Thank you so much. Thank you so much, Monica. Haren, we don't have that much of time. 5, 6 class, how it is possible? We don't have that much time. It's a 2 week training only. And in the next week, I'm not free also, so that I can extend this. I'll see if I can extend this to Saturday, Sunday in the next week. So there I'll explain that if I'll get time. Okay. Yeah, thank you so much, Amandeep. Thank you so much. And same to you all. See, Harendra, see, when I will cover the classification part, na, I'll cover each and every important thing. So I don't think after covering that thing, nothing will be required. And anything will be required. So first of all, let me complete this. Then you all tell me whether it is required or not. Okay. Hardeep, I cannot make you sure about this. Let me see that in the coming session if I'll get time. Okay, so have you all filled the attendance form? Everyone? Yeah, thank you so much. And I can see many participants are coming just for the attendance. Like they are coming in the last 10 minutes and they are filling the attendance form and then go. See, it will not help you in your life. Only getting the attendance and certificate will not help you anything. Knowledge is important. If you get a certificate and if you go for the interview and they will ask you some question and you will not able to answer that, what's the meaning of that certificate? I can see that so many participants are not taking that seriously. Like on Saturday, one participant called me at 9 o'clock and that give me the attendance link. And he was not actually getting to know that on that day there was no class. And he told that I have attended a session and I have missed the link. See how he told me that thing. I got shocked. He told me that I have attended the session and I haven't got the link. But Saturday there was a holiday. If I'm giving this thing, take it seriously. Now, this all knowledge I'm giving you in free of cost. Everything I'm not taking any charge from you. So you should take that as an important class. You should attend the session. You're not getting the importance of these things right now, but later on you'll get the importance of this. Yeah, thank you so much. Okay, then. So I hope you all have filled the form and you don't have any queries. So I'll continue this tomorrow. We'll see you tomorrow for the algorithm. We'll learn about the algorithm, linear regression algorithm in the next class. Okay. And we'll understand the concept of linear regression and then we'll apply this to the data set to predict the salary of an employee. That is what we are going to do in the next session. Okay. No, not TensorFlow. This training is not for TensorFlow. We will use scikit-learn only. Okay. So thank you so much everyone for joining today. Make sure that you have liked this session and subscribe to my channel and do share with your friends and colleagues so that they can also get the benefit of this training. Okay. So good night everyone. Take care. Stay safe and keep rocking. Bye.